I'm sure most of you have heard of the Bored Ape Yacht Club or CryptoPunks. You've definitely heard of NFTs in general. Some of the most common use cases that we've seen so far are profile photos and JPEGs on the blockchain. We've actually even seen some gaming utility for them as well, like with Axie Infinity. But the NFT use cases vary way beyond all that. In today's tutorial, we're going to be going over how to mint songs to the blockchain utilizing NFTs. My name is Anthony with the Blockchain Dojo, where we turn you into a blockchain ninja. So if you learned something new, please like and subscribe for more content. Let's get started. So what an NFT is a non-fungible token, which means that it is a digital representation of an item that cannot be exchanged one for one for anything. For example, $1 is a fungible token, meaning $1 can be traded for any other $1. A non-fungible token example would be like the Mona Lisa. It's a one of one, something that has no one-to-one comparison of value, meaning you can't trade one Mona Lisa for one Mona Lisa because there is only one of them. That basic concept applies perfectly for songs. So while every one of us can hear and listen to some of these songs, only one person or group of people can actually own the rights to a single song. With this contract, we'll actually be minting smart contracts that are representative of an album, and then each NFT on that smart contract will actually be a song. With that will give artists more ownability over their own music, as well as interactivity with their fans by being able to mint and give their songs to their fans on the actual blockchain. You can even take this a step further and implement royalties and other things along those lines, so that the original artist will still always receive a payback or kickback for when the NFT song is sold or transferred. Okay, so let's get started digging into the code here. First, like we do in every other smart contract, is we want to list off the license identifier and the pragma version. Since we are using an NFT ERC-721 standard to store the songs, we're also going to import the Open Zeppelin contract tokens, ERC-721 extensions, ERC-721 URI storage, so we can actually store the token URI on the blockchain. Now with this project, the token URI is actually going to point to an IPF hash where we'll actually be storing the song and then the metadata for the song on the blockchain. Next what we do is we declare the contract, album NFT, and then inherit from the URI storage contract. Now with this, I designed this smart contract so that it works essentially self-contained. So this album has a completion date, meaning once the album is finished, other songs can't be added to the album or minted to this smart contract or changed up. Next, we actually have the artist address, and then we have the album art URI. Now the album art URI is similar to the song URI, where the album art is going to be minted to the IPFS, and then the hash will be stored. Now we'll be using the same album artwork for every single song on this specific album, while the token URI hash for the song will vary based on each NFT. Next, we have the token count and then the track count. Now you're going to see some duplication in this code. I have in this contract, you both have total songs and token count, as well as track songs and track count. So what I mean by this is you can mint a bunch of songs to the NFT contract, but only keep, say, 10 of them as the track or the album. So with that, you can actually see here we have a mapping of all songs. So this is going to take in a uint and map the uint to the song number. And then we have a second mapping of uint to song, which is going to keep track of the track list. So all songs is every song minted to the contract. The track list is the specific tracks that the artist wants to list on the album. Next, we have the only artist modifier, just to ensure that only the artist can modify certain functions. And then we have the album complete modifier. So what this does is it checks that the album has not finished yet. If the album's finished, we don't want someone to have the ability to go in and mint another song from the album. From there, we have the event, which is new song minted, where it will pass in the artist, the token URI, or the token ID and the token URI. And then we actually are defining the song struct down here. This song struct is what's used in these mappings here. So the song struct is going to take in a token URID, the creator, which is essentially the artist. It's going to take in a name, which is the name of the song, and then the current status of the song. The current status is an enum, which we have 3 statuses here: unpublished, album song, and removed. Unpublished meaning the song is minted but not put on the track list. Album song is the song is put onto the track list. And then removed is the album song was on the track list but was actually taken off. Next, what we have here is we have the constructor of the contract, which is going to make the artist the transaction.owner. Next, we have the constructor, which is going to take in the name and the symbol of the album and pass it into the ERC to name the album and then the symbol. And then we're going to pass in the artist is going to be the message.sender. From there, we have our create song function. This is going to be our minting function, where the artist, and only the artist, because we passed in the only artist modifier, can mint a song to the album as long as the album has not been completed yet. To create the song, we pass in a name and then the URI. So the URI will actually be the IPF hash of the song address. Then what we do in order to create the song, we take in a token count and we increment it. Then we grab a local instance of the token count variable and it's where it's currently at. This actually helps to save on some gas. Next, we mint for the msg.sender to the current token number. We set the token URI from the token current number to the URI passed into the function. And then we create a new song struct. So this new song struct is going to take in the token number, the artist, the name, and the song status. Now this artist variable is actually from up here. From there, we're going to pass in all songs. This is just an array. All songs is all of the songs list. So this is the mapping that takes in the current token number and then maps it to the song URI or the song struct. And then we emit a new song minted event and return the current token number. This is very similar to a typical minting function within a normal smart contract, except we just implement a song struct and then add in a mapping for the song struct. Next will be our album management functions. So this is where we're going to set songs to the track list, as well as remove songs and change the status and whatnot. So first, we're going to set song to track list, which is going to take in a song number and then the track spot. So what the track spot is what number you want it listed in the track list number. So if you want it as the first, you put number 1, you pass in 1 here, or if you want it in the last, you put it as number 10 or whatever the last track number will be in your album. Then what it does is we grab the target song from storage and pass in the song number. And then I have a helper function here, update song status. And then we're going to pass in song number and then status number 1, which is a numeric representation of the 0-1 slot, which is an album song or a listed track. And then we're going to add the song struct from storage to the track list under the track spot mapping, and then return true. Next, we're going to update the remove song. So it takes in the song number, and then what it does is it pulls the target song from the mapping. Next, we're going to go over the remove song function, which takes in a song number and then passes the update song status song number and then the number 2, which is the numeric representation for the enum of removed. And then we're going to pass it into the update song status, which takes in the song number and the status. It grabs the target song from the storage and then performs a bit of logic here. If the song status that we're updating to is 1, we're going to increment it and add it to the track list. If it is number 2, we're going to remove song from the track list. And then else, we're just going to leave it as unpublished. Then we're going to remove the target song. Next, we have change song status, which is just very similar to remove song. This is just where you can update the status of the song, whether it's published, removed, or target song listing. This is just an update or helper function. We have a few more other helper function here. We have the remove song, which is we saw earlier passed in here into the update status, which just essentially takes in the song from storage from all songs, and then checks the song status is equal to album song, and then it iterates through the track list and then removes the song from that specific track spot. Next, we change the target song current status to status removed, and then return the current song. The update song status, which we saw earlier, And then we have some setter functions, which finishing the album, once the album's finished, no more songs can be minted. Then we have the set album art URI. This is where you can actually update the album art by passing in the IPFS hash for the new artwork. And then the token count just returns the current token count. There's definitely a lot of code there that we went over, but ultimately it's a standard NFT contract with an updated struct storing specific information. This is just one specific or different use case that you can use NFTs for, but they're not limited to just this. You can use them for tickets, deeds, card titles, and things along those lines. Thanks for staying to the end. If you did learn something new, please like and subscribe and stay tuned for more content.